Look at this. Alright, so today we're going to be doing more proofs, only we're going to do more purely geometric proofs instead of as much algebra. This is where if you did not know your implied statements from before, life's about to get a lot harder. So if you don't know your implied statements, I'd highly recommend you finish memorizing them. Please note that you are memorizing numbers 1 through 35. So everything through the end of Unit 2. We're done giving you new stuff. But all this stuff about the P's and Q's and all your different properties of equality and congruence are going to be on the quiz, as well as the undefined terms and the 4 things you can imply from a picture. So your betweenness, your adjacent angles, your vertical angles, your linear pairs. Okay? So study, study, study. Do all the good things. Because we're going to use this to put this together. And to start this, we're going to remember our law of detachment. Remember that fella? Big fella. There you go. So for the law of detachment, do you remember what happened?
Yeah, if an angle is, like if RT was congruent to TS, then it would also be equal. Okay.
Well, you're thinking of something else. What a law of detachment says is if you have a general rule and then a specific hypothesis, you can use the general rule to get a specific conclusion. Okay? So here I have a specific hypothesis. T is the midpoint of RS. And I got the conclusion that somehow RT is congruent to RS. Which of my implied statements, which general implied statement rule, lets me get from having a midpoint to having 2 congruent things? So a midpoint equals? Implies 2 congruent adjacent.
No, it's collinear.
Oh, it is collinear. Thank you. Get candy. Collinear segments. Let's check that on a picture. Let's make sure that works. So I'm going to come over here and I'm going to draw a segment. And I'm going to call it RS. And I'm going to put T in the middle. Now, if it's the midpoint, then these 2 segments should be congruent. And this says it's RT and TS. Yay! It was RT congruent to TS. So you found the rule that made this true. Try the next one. I've got angle 1 and angle 2 are vertical angles. And somehow I decided that, yes?
Does the arrow go both ways?
Oh, good question. Now, does the arrow in the implied statement go both ways? Yes, but when I was going from T is the midpoint to RT is congruent to RS, I'm only going one direction. And so I say which direction I used the implied statement in. And in this case, I started at midpoint and went to congruent. So I only put the arrow that way when I'm using it in the proof. Okay? I'm so glad you asked that. Very excellent question. So on this next one then, I've got 1 and 2 are vertical. Somehow, this says that 1 and 2 are congruent angles. What implied statement allows me to draw that specific conclusion? Quentin.
Vertical angles.
Yeah?
Implies.
Vertical angles implies congruent angles. So vertical angles, that's what I started with, implies that I have congruent angles. That was the general implied statement that I used to draw that specific conclusion. For number 3, I have what is this telling me with this equal sign? What 2 things are it saying are equal?
The length.
The length of AB equals the length of CD. And somehow segment AB is congruent to segment CD? How? What implied statement allows me to draw that conclusion? You already answered one. I need a new victim. Yeah, go ahead. What you got for me, Elliot?
Midpoint.
Nope, there was no midpoint anywhere. Look, shh. Ask yourself, what do I have here? I have equal lengths. So what does equal lengths imply? Colin?
Congruent length.
Not congruent lengths.
Congruent segments.
Congruent segments. Good teamwork there. Oh, now are you starting to understand why knowing your implied statements would be so helpful? Yeah. Learn and study your implied statements. Stop having fun, gentlemen. You're supposed to be suffering. So on this last one then, sketch it. It says YW bisects angle XYZ. Just a quick little sketch. Doesn't have to be great, but sketch what that would look like. I've got an angle XYZ, and I've got YW bisects it. So W is probably in here somewhere, and it bisected it. And somehow, from just hearing that, this says that angle XYW, that's this guy, is congruent to angle ZYW. That's that guy. How did they get from an angle being bisected to two angles being congruent? Which implied statement? Oh, let's see. Logan raised his hand very nicely.
An angle segment bisector.
Is it an angle or a segment bisector? Did I bisect an angle or did I? So I had an angle bisector, and I'm using my symbol. And what did it imply? Yes.
Two congruent adjacent angles.
Two congruent adjacent angles. Are these two angles adjacent in my picture?
Yes.
Yes, they are. And it said they were congruent, so yes, I used this rule to get two congruent adjacent angles. So see, that's how you can draw these. Do you think you could go backward? If I gave you a given, could you figure out what you could conclude without it being shown?
Yes.
No.
Here's how we do that. We're going to now use our law of syllogism. That's where you can connect two statements. If A implies B and B implies C, then A implies C.
Will these be on our quiz?
Will the new things ever be on today's quiz?
No.
No, only the stuff we've already done on homework.
Jackson.
Okay? So what we're going to do is we're going to prove things in geometry. And to prove things in geometry, we use logic chains. And so we're going to chain all this stuff together using the law of syllogism. And you have to know how to use the law of detachment to do it. So to do it, you ask yourself, what was I given? And then you say, what does that mean? What does that let me get to? This is where you're going to imply something. And then what can I conclude from that? Okay? So, in this first one, I am given that ABC and DBE are vertical angles. Sketch it. Get used to sketching yourself little pictures. They don't have to be beautiful, they just have to be right. So I've got angle ABC, and DBE are vertical, so that means they should make the X, right? So DBE are vertical angles. So this guy and this guy, oh, it's like Black Widow, are vertical angles. Okay? I am given that they are vertical angles. How do you start any proof? What do you always start with?
Given.
Your givens. So I'm going to take this thing that they gave me and I'm going to write it down. So you can always get your givens right. Anytime you do a proof, your given's always right because all you have to do is write down what you were given. Angle ABC is vertical to angle DBE. How did I know that?
The given?
It was a given. They gave it to me. And so I'm going to put my reason there underneath it. And then I'm going to ask myself, okay, I have vertical angles. What's a rule I have with vertical angles that can take me from vertical angles? I want to start getting to where my angles are equal. So what's an implied statement that takes my vertical angles and gives me something else? Yes, what do you think?
Vertical angles imply congruent.
So I can say my vertical angle should imply that I have congruent angles. That's my general rule. So now my law of detachment says, okay, here's a specific set of vertical angles. What is a specific set of congruent angles I can write down now? Which angles will be congruent?
Opposite.
Okay, which specific ones though? I have ABC vertical to DBE. So which angles are going to be congruent? Angle ABC will be congruent to angle DBE. Because of that implied statement you dredged up out of your mind. And now you think, now we're going to use my law of syllogism. I got from vertical to congruent angles. Now I'm going to take those congruent angles and try and head somewhere else. So where can congruent angles take me? What's an implied statement from somebody else? You've helped a lot, and I want to make other people think. What is something that can, if I know that I have two congruent angles? Dig in your implied statement sheet if you have to. Raise your hand so I can see. Oh, okay. Everybody figure it out. When you figured it out, raise your hand. Nobody gets to sit this one out.
What are we solving?
What does congruent angles imply?
Yeah.
I have vertical angles implied congruent angles. Where can congruent angles lead me? Oh, see, lots of people. So, Chloe. Equal measure angles. Okay. So I had verticals that brought me to congruent, and then congruent brings me to them being equal. So now what can I say in this specific case? If ABC was congruent to DBE, what can I get from that now? What's my conclusion?
Measure of ABC.
The measure of angle ABC equals the measure of angle DBE. Isn't that what they wanted me to find? Guess what, y'all? You're done. Because you got to what you were trying to prove.
Let's go.
See? You proved that the measure of angle ABC equals the measure of angle DBE.
Are we gonna do that like on a test?
Oh, heck yeah! And we're going to do it all year. And we're going to do ones that take a whole page to do. I know, right? Should we start with just the baby ones for now?
Yeah.
Okay. Shh. So this is called a logic chain. We're just chaining together our logical implied statements to figure out how to get to a logical conclusion. This is deductive reasoning. Oh, wow, that's why we talked about that on day one.
That's crazy.
Okay, I know, it's totally whack. So, this first one, given AB is bisected by MC at point M. Sketch it. I'm done.
I need like 10 more.
Whoa, I did not.
Now, could my picture maybe be up that way?
Yes.
Yeah, you could point it any way, but you should have a segment AB, and you should have a point M where it is bisected, and point M is the end point of a ray that's named MC. Okay. So now that you've drawn it, let's do our chain. So what do we always start with in a proof? The given stuff. So let's put our given. So, watch this. I'm going to write it shorter. Instead of saying AB is bisected by, I'm going to put MC bisects AB at M. How did I know that?
Given.
It was given.
Let's go, guys.
Now let's think about what I started with here. I started with something bisecting a segment. What is a thing that bisects a segment called? So for my implied statement, I should think, wow, if I'm starting with a segment bisector, what can I imply from that?
That it intersects.
That it intersects at a midpoint. And so you write down your implied statement and you think, okay, in this particular picture, I have my segment bisector. What will be my midpoint then? Because I started with a bisector, I need a specific midpoint. What will the midpoint be? M. So you come up here and say, okay, M is that midpoint. Because I said it was bisected at point M. And so now, let's take our law of syllogism. Let's make a new link to our chain. I've got what?
Midpoint.
A midpoint. What could a midpoint lead me to? Somebody new. I know you got these. Somebody, you've answered a bunch too. I appreciate that, but you've answered a bunch. So next victim. Okay, you haven't answered as many, Zach. Two congruent collinear segments. And so now we think, okay, M was my midpoint. What are my two congruent segments going to be that are collinear because of M? Raise a hand, raise a hand. Luke?
AN and MB.
AM will be congruent to MB. Are these two guys congruent?
Yes.
Yeah. Are they collinear?
Yeah.
We're
Yes.
showing all
Yes.
steps to get that?
Yeah.
Oh.
Wait, it's what?
Wait, no. Wait, never mind. You don't even have to. I man over this.
Oh, I didn't say it. I didn't say the word.
Okay, so now, shh. So I have two congruent collinear segments. Do I want to go back to midpoint and then back up the chain?
Not really.
No, I need to go somewhere new. So I'm going to think about this. I have two congruent segments. What do congruent segments imply? Yes, equal lengths. Well, I'm trying to show that AM equals MB. And I only had congruent. But now that I had congruent things, if I have congruent things, what does that imply? Equal stuff. So now I can say that AM is equal to MB. If you know your implied statements, they literally point you the way to the answer. And then all you have to do is go back and figure out, well, what specifically are my things that I'm talking about? Okay? Shall we try another?
Yeah, sure.
Okay. I'm given that AB is perpendicular to CD at point E. Sketch it. Sketched. Is your sketch? Make it so you can read it. And then what do we always start with? You're given. So I'm given that AB is perpendicular CD at point E. Now let's see where I want to go. It wants me to show that the measure of angle AEC equals 90 degrees. So that's my stopping point. So I need to just keep chaining implied statements till I get to AEC being a 90-degree angle. And so I go, cool. Okay, and let's mark that in the picture. Let's find AEC here. There it is. That's the one that I want to equal 90 degrees. So you go, okay, looking in my givens, I'm given perpendiculars. So you start to think, do I have any implied statements that talk about perpendiculars? Okay, Haley, what do you think? Your name's not Haley.
Perpendicular implies right angles.
Perpendicular lines implies right angles.
And a midpoint.
Okay. Now, there's several right angles in this picture. So when I use my law of detachment to come up with my specific conclusion, which one do you think will be the most helpful to getting the measure of angle AEC being 90?
BEC?
Should I use BEC to tell me that AEC is 90? Why don't I just say angle AEC is the right angle I can get to?
That's a trick question.
Okay, because if my perpendicular lines lead to right angles, I think I'm going to focus on that specific right angle. So angle AEC could be that right angle. Now, my law of syllogism says I can connect up a new link to my chain. So I'm starting with a right angle. What could that lead me to, knowing that I have a right angle?
90 degrees.
And there's a couple things. It could lead me back to perpendicular lines, but do I want to go backward? No, so I need something else that right angles leads us to. And what is that implied statement?
90 degrees.
That is not exactly what it says. Tell me exactly what it says. Right angles implies,
Congruent.
nope,
Measured angle equals.
the measure of the angle equals 90 degrees. Shh. So now your law of detachment's going to say, okay, if AEC is my specific right angle, what can I conclude? That I can conclude that the measure of that specific angle, that's an A, equals 90 degrees. Should I keep going?
No.
No, because that's what it told me to prove. I'm done. Well, did I prove what I wanted to prove?
Yes, ma'am.
QED, I'm done.
Like with the whole thing?
Well, with that problem. Okay.
Can we go back to regular math?
This is regular math. It's just math you've not seen before.
Well, we are doing numbers.
Who says numbers are the only thing in math? Geometry came before numbers.
Yo, wait.
Stutters.
But then
Okay, so,
numbers get into it.
well then somebody decided to put numbers into it.
Why'd they make that numbers?
Don't ask me, I wasn't there. So next, new picture. Shh. Given ray BD bisects angle ABC. Sketch it. Don't make it more complicated than it needs to be. Give yourself an angle. It's ABC. And then B to D should bisect it. Doesn't have to be fancy. And then you write your given, so I have that ray BD bisected angle ABC. And yes, I know it's crowded. If you write big, you can take this to another piece of paper if you need to, if this is just too obnoxiously small for you. Okay. Okay. So, I want to prove that angle ABD is congruent to angle DBC. That's where I'm trying to take this chain to. Okay? So what's the first implied statement I can think of that could start this chain? Oh, I am given an angle bisector. So an angle bisector might lead me somewhere. What do angle bisectors imply? Two congruent adjacent angles. And so now you have to go back to your picture and think, which two angles am I going to say are congruent?
ABD and DBC.
So you're going to say angle, here's the first one, angle ABD. And then my second one will be angle DBC, right there. Then what?
You're done.
Then you're done. How do you know?
Because it's
It matches what you were trying to find. One-step proof.
Wait, how did you get it from there to there? From like Kevin to that?
I knew I had an angle bisector, and so I thought of an implied statement that started with angle bisector. An angle bisector implies two congruent adjacent angles. So I looked at my picture and I said, if this is my angle bisector, what will be the two congruent angles? It's going to be the one on the left and the one on the right. And so I wrote them down. It's magical. Now this next one, it's a little bit more sticky. So I'm going to get out a piece of paper for this fella. Big fella, whale. Okay. So for a linear pair, let's try one with a linear pair in it. Ooh, linear pair, that was special. What's special about linear pairs? Only you know? What do you know about linear pair?
Supplementary.
Well, that's the implied statement, but what else do I know about linear pairs, yeah? No, they don't. Well, I mean, they do, but that's not what it implies. Linear pair is something that you can imply from a picture. What else can be implied from a picture? Adjacent angles, vertical angles, and betweenness. Okay, just reminding you that you have to know those. Shh. But here, I didn't even have to imply it from a picture. They told me I have a linear pair. Draw it. And, oh, by the way, guys, this shouldn't say congruent here. This should just say the two angles, so angle ABD and angle DBC form a linear pair. It shouldn't say they're congruent. That's a typo. Correct that before it gets you all confused. Scribble out the congruent and just put and. So I'm going to draw that as a linear pair. So I've got angle ABD and then angle DBC should form a linear pair. And linear pairs form a straight line when you stick them together, right? And look, they're stuck together and they form a straight line. So now to start my proof, I'm going to put my given. BD, sorry, that was the one above it. Mrs. Cerna. Angle ABD and angle DBC are a linear pair. That was what was given to me. And let's see where that can lead me. I have a linear pair. So I start thinking, what could a linear pair imply?
Straight line.
Really, that's the...
Supplementary angle.
Think of your implied statement, guys. Okay? Linear pair implies supplementary angles. That's your implied statement. You have got to memorize these, y'all, because you won't be able to do these proofs if you don't know your implied statements. Quizlet is still available in Canvas on every single day's module. Okay? Shh. Well, they told me that this was a linear pair, so what are going to be my two supplementary angles that I get from that linear pair?
ABD.
Angle ABD will be supplementary to angle DBC. Or you could say angle ABD and DBC are supplementary. There's more than one way to word that. Okay? Now I'm going to try and show that angle ABC is a straight angle. Do I see angle ABC in here yet? No? Let's see if we can drag it in. Let's keep going. Now I have supplementary angles. So let's use our law of syllogism. Where could supplementary angles now lead me? Somebody new. Somebody on this back table here. One of y'all four. What do supplementary angles imply? Yes, Camilla?
2 and equal 180.
They don't just equal 180, they sum or add to 180. So two angles that sum to 180 degrees. You gotta say they add up to it, otherwise I'm gonna think each angle individually is 180, and that's not the case. So now that I know that supplementary angles should lead me to two angles adding to 180, here are my supplementary angles. What angles am I going to say add to 180?
ABC.
Those ones. But can I add angles?
No, you have to.
I have to add their measures. So the measure of angle ABD, I'm going to add it to the measure of angle DBC, and that's going to equal 180 degrees. Oh no, you have to write more letters and things. It's still not as much as you would write if you're in an English class. Just saying. You don't write nearly as much in here.
I don't write.
Yeah, we don't.
Okay? Now, I have two angles that add to 180. Do two angles that add to 180 have an implied statement that lead anywhere else?
Probably.
Yes.
No.
Most likely.
No.
No.
They lead back to supplementary, but is there anywhere else it leads?
No.
So, okay, we're at a dead end, but we have not proven it's a straight angle.
Then it's not a straight.
Oh no, we're just not done. I need to go back to my picture and look for another given.
No.
Mr.
Hey, no whining.
Thou shalt not.
So let's go back. I was given that they're a linear pair. What else can I see in the picture that I have not yet talked about? Yes.
B is in the middle.
Being in the middle is not something I can get implied from a picture. So what are the four things I can imply from a picture? I can imply vertical angles. Do I have vertical angles in that picture?
No. Between
I can get betweenness. B is between A and C. Is that going to help me with angles, though?
No.
Jason.
Maybe not. What else can I get?
Jason.
Adjacent angles. Do I have adjacent angles in a linear pair?
Yes.
So let's say that they're adjacent. So angle ABD is adjacent to angle DBC. That's a given that I can get from the picture of linear pair. Yes.
I'm gonna need that.
Yeah, that's why I got a separate sheet of paper, because I write too big for this space on here. So I cannot just say they're a linear pair, I can specifically say they're adjacent. Now, let's think about that for a minute. Does having adjacent angles have an implied statement that leads me somewhere?
AAP.
Angle addition postulate. You are so smart. But now you gotta be even bigger brained.
No.
Oh, if these, please don't talk over me, I'm trying to record. If people are trying to take these two adjacent angles, what would be getting added in my angle addition postulate if I've got angle ABD adjacent to angle DBC? What would they be adding up to in my angle addition postulate?
180.
No,
90.
ABC.
no. It well, ABC would be what it is, not 90, not 180. Remember, angle addition postulate says part plus part equals whole. What is the whole angle?
180.
No, it is angle what? ABC. So I can say that the measure of angle ABD plus the measure of angle DBC can equal the measure of angle ABC. Part plus part can equal whole. And that's all I can say from AAP, is that part plus part equals the whole angle. Do I have straight angle yet?
No.
Okay, so this is where magic stuff happens. Because I have two chains going on right now. I'm going to bring those chains together. Watch this. I can either use the substitution property or the transitive property. The transitive property lets me say that if I have two things equal or congruent to the same thing, then they are equal or congruent to each other. The substitution property lets me replace a part of an equation with something else. Okay? So I'm going to look here, and I'm going to get my highlighter now and say, okay, do I see any things that are the same at the ends of my two chains? Oh, this one up here has this sum. And this chain has the exact same sum. The measure of angle ABD plus the measure of angle DBC. And look, 180 equals that green chunk, and the measure of angle BC equals the green chunk. I have two things equal to the green chunk. So what can I take from that? If two things are equal to the same thing, then they equal each other. So this 180 can equal this ABC.
Do you understand this?
Nope.
Okay, so Reese, see how I have two different things in the two chains?
I do.
Are they both equal to the same green garbage? If two things are equal to the same thing, can I say that they're equal to each other?
Yes.
What rule lets me say that?
Transitive.
Right here on my notes I just circled.
Transitive.
That's my transitive property of
Transitive property.
what? Equality or congruence?
Congruence.
No,
Equality.
equality, because see, these have equals in them. If I'm using equal signs, it's the transitive property of equality, because I'm using equal signs.
When is this test?
There's a back.
No.
Crap.
Next Wednesday.
Now,
Is that for you, Ida?
have I proven what it asked me to prove?
It is. Straight angle.
Have I said straight angle yet?
No.
Then I'm not done yet. Shh. So now I have to keep going. I'm almost done though.
I don't believe you.
Okay. Now that I have the measure of angle ABC equals 180, where can I go from the measure of an angle equaling 180 degrees? What does that imply?
Straight angle.
That implies a straight angle. What angle will be the straight angle?
ABC.
ABC. So angle ABC is straight. because that's what was implied. So it's a straight angle. Is that what I was trying to prove? Finally, QED, quadrant demonstratum. That's what I was trying to prove. Okay.
Sounds like some Scooby-Doo movie.
Well, there's a fancy Latin phrase called quad erat demonstratum that just basically says, hey, that's what I was trying to prove. And so mathematicians, when we finish a proof and say, hey, that's what I was trying to prove, we just say QED, quad erat demonstratum. It's just a math nerd thing. You don't have to know it.
And you enjoy
Would it be
this?
like a bonus
Heck yeah!
question?
Because I'm solving this puzzle. What do you not understand? Okay, shh. Now, somebody said they didn't understand. So let's go back through it so we can make sure everything chained up. Y'all who already know it, can you keep it down so the person who wants to know can listen? Gentlemen. Hey, pretend you're paying attention though. Putting your head on your face is not good acting. I'm not convinced you're listening if your head is down.
It's on your face.
Okay? So I started off with being told I have a linear pair. I said that's what I was given. And then I thought, well, what could linear pairs imply? Well, my implied statement says linear pairs could imply supplementary angles. Okay? And so I said, what pair of supplementary angles do I have? I have ABD is supplementary to DBC. I used that law of detachment that said I could get a specific answer. If ABC and DBC are the linear pair, they better be the supplementary angles. Then I took those supplementary angles and came up with a new implied statement. Supplementary angles imply that I have two angles that sum to 180. So if these are my supplementary angles, could I say that their measures add to 180? And I did. Those specific angles added to 180. But then I couldn't think of anything that gets from 180 to things that are added to 180.
I get the bottom part.
And so then I made a new one at the bottom and said, okay, I got stuck at two things adding up to an angle. But then I said, look, did you notice that these two things equaled the same thing? So I could say they equaled each other by the transitive property. And from there, I have one angle equaling 180, so one angle is a straight angle. Okay? And so the transitive property and the substitution property are the ones that are most often going to be what we use to bring two logic chains into one. So if you see two things equal to the same thing, it'll be transitive. If you just replace a part with one little thing, that'll be substitution. Okay? So turn your paper over. Now you thought we were writing a lot of words. And so the math gods say, since you were going to whine about that, let's make you do some real writing. So we're going to do a paragraph proof. And I'm going to show you the template for the paragraph proof. So this is my I can't spell, paragraph proof template or frame. So this is what paragraph proofs look like. Okay? You're going to start with given something. You're going to write this as a sentence. Given something. Now you are allowed to use mathematical symbols in your paragraph so you can do less writing. So if you're getting more fluent in your symbols, you can write fewer things. This is why I majored in math, so I could write fewer things. My sister majored in English. She wrote 10,000 word essays. I don't have to write nearly as many words. So if you're given something, you say, then whatever I conclude. And then I say, by whatever implied statement or property or whatever else. Okay? Now, if this is where you had to be done, you stop there. We had one like that. you had this one where I said that this is literally how the paragraph proof would look. Given that BD bisects angle ABC, then angle ABD is congruent to angle DBC by what rule? What was my rule that let me get that?
Angle bisector.
Angle bisector implies two congruent adjacent angles. And that would be my whole paragraph. I'm done. Because that was what I wanted to prove. But what if one line doesn't get me to where I wanted to prove? Now I have to do another loop at it. So I say, since whatever you had here, since that thing is real, then I can say something else by another rule. And if this thing that you get, if this conclusion is what you were trying to prove, you can be done. But what if this conclusion isn't what you were trying to prove? Then you keep going. Repeat as necessary. You know, rinse and repeat like it says on the shampoo bottle. Wait, people actually read the instructions on those? Yes. There's actually instructions on a shampoo bottle. People not using common sense is why we have to have instructions on a shampoo bottle, or why we have to say, caution, coffee is hot on your cup from McDonald's.
Yeah, because you were
And that's why we have to spell everything out here. So using that template, and we've done logic chains, let's try a 2-column proof like we did for algebra, and a paragraph proof like we had here. Let's just make, this would be 3 different ways you could do it. You could do it using a logic chain, you could do it in a 2-column proof, or you could do it in a paragraph proof. You're going to be fluent 3 different ways. So, hey, if you want to insult the math gods, they will give you more. Do you want to do that? Then do not insult the math gods. So I am given that xy is perpendicular to AB at n. Sketch yourself a picture for that. Always sketch a picture. So I've got xy is perpendicular to AB at n. And what am I going to try to prove? That the measure of angle YNA, so here's YNA, this red angle, I need to prove that that equals 90 degrees. That's what I'm going to do. And so what do we always start with? The given. So I'm going to make my 2 columns. I have my statements on the left, and I have my reasons on the other side. And the first thing I can state is that xy is perpendicular to AB at n. That's a given. And so then I've got to think, what thing over here can lead me someplace new? Well, what do I have here? I have perpendicular lines. So where could that lead me to?
Right angles.
It could lead me to right angles. So that's the reason I'm going to use. But now I got to think, where does that lead me? What right angle does it lead me to?
A and Y.
Now there's a lot of right angles in that picture, huh? Which one's going to be the most helpful for getting this guy? Probably angle YNA. So I'm going to say that angle YNA, is that true? Look in the picture. Does it look like a right angle if I'm perpendicular? Okay, so angle YNA is a right angle because perpendicular lines implied right angles. And then I think, where could that right angle lead me? That is, right angle implies what?
90 measure.
The measure of the angle equals 90 degrees. Don't leave stuff out. You've got to put the whole implied statement. Learn them, love them, live them. So over here, which angle am I going to say equals 90 degrees? So I can say the measure of angle YNA is the one that's equal to 90 degrees because that's where my implied statement tells me to go. Is that what I was trying to prove?
Yes.
QED, I'm done. Now, let's try writing that as a paragraph. So what do I start with? Given. So you say given what? XY is perpendicular to AB at N. Can I use symbols in a paragraph?
Yes.
Sure. So given that, then what did I say? Since I have that, what did I get? Then what?
Angle Y.
Angle YNA is a right angle. By what rule? I said it was a right angle. What rule gave me that? Perpendicular lines implying right angles. And then I said, since I had a right angle, so since angle YNA is a right angle, then what did I say? The measure of that angle equaled 90. By what rule did I get that one? The right angle implying that the measure of the angle equaled 90 degrees. So here it is written as a 2-column proof. Here it is written as a paragraph proof. The further you go in mathematics, the more often you use paragraph, actually. When you read math books, proofs look like this. Given that this and this is happening, then you can say this by this rule. And then you can say this by this rule. And then you can say this next thing by this rule. Therefore, you are done. Only they take up pages. And they're full of symbols, so you have to know the language of the symbols too, which is why learning your implied statements is important, because you get familiar with the symbols. You get used to using all this stuff. Okay? Now, would you like to do another right now together? Or would you like to start your quiz? Do you have more time for the quiz? Well, that's not an option, so... Okay. So, let me turn off recording.
You don't learn anything when you do that.
I did my